This is what our modern periodic table looks like. It has 18 vertical columns, called groups, and 7 horizontal rows, called periods. The elements in the middle are called transition elements, and the 2 rows at the bottom are called the lanthanides and actinides. For learning general periodic trends, we usually don't focus on these elements because their trends are more complex. Instead, we'll focus on the main group elements, which are the elements on the left side and the right side of the periodic table. So let's get started. To understand these trends, let's use the third period as our example. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Every trend we'll learn today follows these elements. Let's begin with our first trend. Valence electrons are simply the electrons present in the outermost shell of an atom. Let's count them. Sodium has 1 valence electron, magnesium has 2, aluminum has 3, silicon has 4, phosphorus has 5, sulfur has 6, chlorine has 7, and argon has 8. Notice the pattern? Every time we move one element to the right, the number of valence electrons increases by 1. So our first trend is simple. From left to right, valence electrons increase. Now let's look at valency. Sodium has a valency of 1, magnesium has 2, aluminum has 3, silicon has 4. Up to silicon, the valency keeps increasing. But after silicon, it starts decreasing. Phosphorus has a valency of 3, sulfur has 2, chlorine has 1, and argon has 0. So the pattern becomes 1, 2, 3, 4, then 3, 2, 1, 0. Now let's move to our second trend. Atomic radius simply means the size of an atom. Many students think atoms become bigger as we move from left to right, but that's actually the opposite. Even though electrons are being added, they are entering the same energy level. At the same time, the nucleus keeps gaining more protons. More protons create a stronger attraction that pulls the electrons closer, so the atom becomes smaller and smaller. That's why atomic radius decreases from left to right. You can also think about it like this. If sodium has this much size, then the next element, magnesium, will be slightly smaller. Move one more step to the right, and aluminum becomes even smaller. Then comes silicon, which is smaller than aluminum. As we keep moving from left to right, every next atom becomes slightly smaller than the previous one. That's why atomic radius decreases from left to right. Now let's move to our third trend. Ionization energy is the amount of energy required to remove an electron from an atom. Think about it. If an atom is small, its electrons are held very tightly by the nucleus. Removing one of those electrons becomes difficult. Since atoms become smaller as we move from left to right, the nucleus holds the electrons more strongly. So more energy is required to remove an electron. Therefore, ionization energy increases from left to right. Now let's look at the fourth trend. Electronegativity is the ability of an atom to attract shared electrons in a chemical bond. As atoms become smaller, the nucleus gets closer to the bonding electrons. Because of this, it can pull those electrons more strongly. So as we move from left to right, the attraction for bonding electrons increases. Therefore, electronegativity increases from left to right. Remember, we usually don't consider noble gases because they rarely form chemical bonds. Now let's move to the fifth trend. Electron affinity is the energy released when an atom gains an electron. As we move from left to right, atoms become smaller and get closer to completing their outermost shell. Because of this, they attract an incoming electron much more strongly. So, in general, electron affinity increases from left to right. Now let's discuss our final trend. Metallic character tells us how easily an atom loses electrons. Metals lose electrons very easily. But as we move from left to right, atoms hold their electrons more tightly. So losing an electron becomes more difficult. As a result, the metallic character gradually decreases. Therefore, metallic character decreases from left to right. Now let's study the opposite direction. Instead of moving from left to right, this time we'll move from top to bottom. We'll use group 1 as our example. Lithium, sodium, potassium, rubidium, cesium, and francium. Let's begin with the first trend, valence electrons. Notice something interesting. Every element in group 1 has only one valence electron. Lithium has one, sodium has one, potassium has one, rubidium has one, cesium has one, and francium also has one. So no matter how far we move down a group, the number of valence electrons remains the same. Therefore, from top to bottom, valence electrons remain the same. Now let's move to atomic radius. As we move from top to bottom, the size of the atom increases. Let's see why. Lithium is the smallest atom in this group. Move one step down to sodium. Sodium is bigger than lithium. Move another step to potassium. Potassium is bigger than sodium. Next comes rubidium, which is even bigger. Then cesium becomes larger. And finally, francium has the largest atomic size in the group. So every time we move one step downward, the next atom becomes larger than the previous one. But why does this happen? Because every step downward adds one completely new electron shell. As more shells are added, the outermost electrons move farther away from the nucleus. That's why the overall size of the atom keeps increasing. Therefore, atomic radius increases from top to bottom. Now let's move to ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom. As atoms become larger, the outermost electron moves farther away from the nucleus. The nucleus cannot hold that electron as strongly, so removing the electron becomes easier. If removing an electron becomes easier, less energy is required. Therefore, ionization energy decreases from top to bottom. Now let's understand electronegativity. Electronegativity is the ability of an atom to attract shared electrons toward itself. As atoms become larger, the bonding electrons are farther away from the nucleus. Because of this, the nucleus cannot pull them as strongly, so the attraction decreases. Therefore, electronegativity decreases from top to bottom. Now let's look at electron affinity. Electron affinity is the energy released when an atom gains an electron. As atoms become larger, they cannot attract an incoming electron as effectively. So, in general, electron affinity decreases from top to bottom. Finally, let's understand metallic character. Metals lose electrons easily. As we move down a group, the outermost electron gets farther away from the nucleus. Because of this, it becomes easier to remove. When an atom loses electrons more easily, its metallic character increases. Therefore, metallic character increases from top to bottom. Now let's quickly summarize everything. From left to right. Valence electrons increase. Valency increases from 1 to 4, then decreases from 4 to 0. Atomic radius decreases. Ionization energy increases. Electronegativity increases. Electron affinity generally increases. Metallic character decreases. From top to bottom, valence electrons remain the same. Atomic radius increases. Ionization energy decreases. Electronegativity decreases. Electron affinity generally decreases. Metallic character increases. Once you remember these simple periodic trends, you'll be able to predict the properties of almost any main group element just by looking at its position in the modern periodic table. And that's the power of the periodic table. Master these trends, and chemistry becomes much easier. Thanks for watching, and I'll see you in the next video.